All right, welcome to video 3 for week 16, where we're going to talk about volume, which we all know the mathematical definition of that, which is how much space an object takes up. All right, and we're always going to have unit, cube, right? It's like we literally take an inch and we make a cube out of it. That's how many cubes that space would take up. So we say that inch, right? Cubic inches or cubic feet or feet cubed. And it literally means if we make a cube that has 1 inch on each side. So that's the volume. We're going to have a couple of volume equations here. I will post some notes at the end of this, which are all the formulas for all the shapes we're going to do in this unit. But for the first part, we're just going to talk about how to think about volume of a cylinder or prism. So for both of these shapes, right, if we go back to the ones that we used in my video, here we have a triangular prism, right? The bases are both triangles. Right, here it is standing vertically up. And it's kind of like we took a triangular piece of paper and we just kept adding more and more pieces of paper, or like cards or slices of wood, or however you want to think about it. We just kept adding the base to itself over and over and over again till we get this stack of bases that form a prism. Same with the cylinder, right? It's like if we took, you know, like those cardboard coasters, and if we just stacked them on top of each other over and over and over and over and over and over and over until we formed a cylinder that has, right, the same two bases, top and bottom, but it's a 3D shape now. So the volume isn't too bad for this. The formula that we're going to use is the area of the base times the height of the prism, right? B is the area of the base. H is the height of prism or cylinder, right? And that height is always going to be perpendicular to the base. Right, it should never be on the base, it should be coming out of the base. So let's look at an example here. Here we have a shape, as we talked about in the last video. We can kind of take the clue from this worksheet and say anything with those red perpendicular symbols on it, that's going to be the base. So here we have, if we look at it carefully, right, that's actually a square prism, or we can say that's a rectangular prism, whichever one, right, because a square is a type of rectangle. So here we would follow the same steps as we did for area, for surface area or lateral area. Here we have the base, which for a rectangle or a square we do length times width, so 11 times 11, so we get 121, and then square yards, right? But then when we start to find the volume, right, our volume, capital V, is just the area of the base times the height of the prism. So here our area of the base is 121, and the height, right, not 11, not 11, we're looking for something that comes off of the base, right? So here is, right, it's perpendicular to the base, so here the height of the prism is 5. So if we do 121 times 5, we get 605. Our unit is yards, and then we cube it because we're talking about volume, right? So these problems are actually quicker than area because we don't have all these extra steps. Volume is a formula right away. And one formula that you might have already talked about for a rectangular prism, only for rectangular prisms, right, is volume equals length times width times height. You might have already talked about that, but notice again, length and width is already the base, so we can just do base times height. And what's best about that equation is we can use it for all of our prisms and cylinders. It's not a formula that's only for rectangular prisms. So let's actually look at that. Here we have looking at it right away, right? And again, we see the red symbol there, so that means here is our base, right? This is a triangular or triangle prism. So when we want to find our volume, right, we need the area of the base times the height of the prism. So let's find that out first. The area of the base, that is our triangle, so we need 1/2 the base of the triangle times the height of the triangle, right? And again, we have to be careful about not being confused about all that. Then, like I said, in other problems, we can copy down all the information that we have onto all pieces of our diagram. So here we have to be careful, right? We have 3, 4, and 5 all around the shape, but the base and the height of the triangle have to be perpendicular. So that means the area of the base is 1/2 of 3 times 4. So that's 1/2 of 12, which is 6. And our units are inches, and then we square it for area. And then when we find our volume, we take the area of the base times the height of the prism. So we're using the same lowercase h for both of this, but they mean different things in the two different parts. So here we have area of the base, which was 6, times the height of the prism, which is 2, right? The prism is on its side, so the height isn't vertical. It's the thing coming off of the base, right? So that's the 2. So we get 12, and then our unit, and then for our volume, we have a cube, all right? Again, much faster than area. So let's try it with another shape. Here we have this weird looking thing. I'm taking the clues that the worksheet gives me, the red dotted line and the right angle symbol, so that's our base. So if we look at that, first question would be identify the 3D shape. Here it is a trapezoidal or just trapezoid prism. The next part is going to be finding the area of that trapezoid. So here, the area of the trapezoid is 1/2 times the height of the trapezoid, base plus base. So we do 1/2 times the height, which was 5.5. And then the two bases, right? I don't see it clearly, so let's do what we keep saying we're going to do. Label every side. 12. So this is 12. If that's 16, this is 16. This is 16. This is 16. That's 7. This is also 7. All right. So that means the two bases of the trapezoid are 12 and 7. So here we're going to have a messy number. So let me do this in the calculator. We have 1/2 times 5.5 times 19. So we have 52.25 is the area of the trapezoid. So that would be in square yards. And then to find the volume, we take the area of that trapezoid times it by the height of the prism. So that's 52.25, and the height of the prism is the 16, right? Because it's coming perpendicularly off of the base, so 16. So then we get 836 as our answer, but we need that unit, which would be yard, and then with the cube because we're finding the volume. So we keep doing this no matter what the shape is. We do area of the base times the height of the prism. So we only have 3 more examples to do for this video. So let's look at this one again. We want to identify the shape. We're looking for those clues. All right. Here we can see the 3 rectangles and the 2 triangles, which means the triangle is the base. So we have another example here of a triangular prism. So to find the area of the base, we need the area formula of a triangle, which is 1/2 base times height. Here we have to be careful, right? Here we can see that the height is inside the triangle, and that's 5.5 5.1. And then we need the side of the triangle that's perpendicular to the height. So that's going to be the 8, right? Not the 7, not the 6, but the 8. So here we would have 20.4, and our units are feet squared for area. And then for volume, we do the area of the base times the height of the prism. So that's that 20.4. And the height of the prism, we look around the diagram, right? If that's our triangle as the base, we're looking for a piece that is not on the triangle, but coming off of it. And that would be the 4, right? Each of those little pieces, the heights of that lateral area, the height of the prism would be 4. So here we would get 81.6, and again, our unit are feet, but we cube them because we're finding volume. So those were our examples for prisms. Now let's look at a cylinder. The idea is still the same, right? We know that, number one, we know this is a cylinder. But to find our volume, we do the area of the base times the height of our shape, which here, the height of the cylinder. We could still use the same setup, find out the area of the base, which is pi r squared. So that's pi times the radius, which they did give us, which was 12, right? Squared. So we're going to get a big number for this. All right, so in my calculator, I'm doing pi times 12 squared. So I get, and this is going to be approximately equal to 452.39 feet squared. So I can plug that in now. So 452.39. And then the height of the cylinder is our 6. And then feet cubed because we're doing volume. You might, if you look it up, right, the volume of specifically a cylinder is pi r squared h. And that's just taking the two pieces together and getting rid of that kind of the middle step of finding the area of the base. But some problems I might have you find lateral surface area and volume all in one go. So finding the area of the base is just a quicker way to do it if you're doing everything at once. Which your project at the end of this unit will be that. So one more example, another cylinder, but here we have our cylinder on our side. So again, this is a cylinder because our base is a circle. The area of that circle would be pi r squared. So we do pi square radius, but be careful looking at this. See how the red line goes from side to side. Here's our center, so that means half of that is 9. So we'll get in our calculator when we do that, we get 254.47. Our units are centimeters, so squared for the area. But then when we find our volume, we do base times the height of our cylinder. So we get 254.47 times the height, which is 11. Right, here's our circle. The thing coming off of that circle is the 11. So here, we already rounded once, so we should have approximately equal to the entire time. We multiply that 254 by 11. We get 2,799.16 centimeters cubed, right? So that's how we found the volume, which is how much space something takes up, for both prisms and cylinders.